Welcome to lecture 11, the last of my series of lectures on climate science. We are going to talk about a very specific proposal. It's sketchy but specific. We're going to talk a little bit about negative emission technologies and what they might look like, because they are some things we might do in the future. And then we'll do a very quick summary of the course. So let me zoom over to the screen share here and here. So this is the second part of what we can do. And I boldly called this a plan to save the world from climate change. I wanted to take a specific stand because it's important to sort of put up a straw man and say, what would it really take to attack this problem? I'm not bold enough to suggest that I have an answer, but there have been things I've read and thought about and talked with many people about and listened to other people talk that resulted in this kind of thinking. So I have three kind of phases here. Let's stick myself up there. So the first phase is to act quickly and capture maybe 500 gigatons of the carbon budget by 2050, maybe more. So I was trying to be conservative here, and I said, what would I do right away out of the gate if I had some power over this situation? The first thing I would do is accept the California Compromise on CAFE standards and implement it as a federal regulation. As you know, in the Obama administration, we had a CAFE standards regulation. It was, I don't have the details in front of me, but it asked for increases in mileage standards up to, I think, doubling from maybe 22 or 3 to 45, 46, maybe even higher miles per gallon. By a certain date, sometime like 2030 or something like that. When the Trump administration came in, they said, we don't want to do this. California has held out as a state that received an exemption a long time ago to set standards because of the pollution problems they had in like the Los Angeles area with smog and so on. And so they had their own standards, which were then adopted by the country, because basically car makers didn't want to build two sets of cars. In reaction to the Trump proposal, California proposed a compromise. That ended up being some reduction of the proposed standards, the standards that had been put in place by the Obama administration, but still asked for a substantial increase. And that, as far as I can tell, has been rejected. And so we're basically saying, keep the CAFE standards exactly what they were a while back. And the details of that you can find in newspapers and so on. It is very important. It is very useful for the United States to have CAFE standards that would be increasing. It would make a big difference. And one can argue the efficiency of cars would pay for the standards at some point. We need a measurement standard for methane leaks. The other thing the Trump administration has done recently is eliminate the possibility of such a regulation. I mentioned earlier that there is a big debate about how big the leaks are. And I believe there are bad players and good players out there amongst gas producers, so I'm not painting the whole industry with one color paint, but I would just say that people who fly airplanes around with detectors and so on find big leaks in local areas, as much as 13% of production, 10% of production. The industry thinks it's like 1.5 or 2. I think we should set a standard of 1%. There's a chance we will have a much better measurement tool in place soon, with a satellite being put up and funded by the Environmental Defense Fund. And I think it would be a very useful thing to do. We would like natural gas to be a transition fuel. It simply cannot be a transition fuel if we're going to leak it all over and leak it into the atmosphere at a rate above 2% or something. And in addition, when you think about it, these leaks, 1% or 2% of production is a lot of money. So companies should be concerned about fixing these leaks. It's an economic thing. I understand that finding them and leaking them, fixing them can be expensive, but presumably it would pay back. Now a big one. We need to reduce and eliminate coal as a fuel for electricity production. And the big thing I should say here is in the world. And in order to do this, we need to do it with municipal bond-like funding. Municipal bond funding is an interest rate like 2 or 3%. If we provided international leadership, I think we could do this around the world and it would make a big difference. We might need to share some of our ability to do fracking for natural gas production with countries like China in order to do so, but I believe it's well within our capability to do that. There is no reason not to incentivize the purchase of hybrids with some kind of rebate system. Hybrids are not that much more expensive than regular cars anymore. They often get 30 to 50% or maybe even doubling sometimes the mileage of a conventional car from an industrial compression engine of the same industrial combustion engine of the same vehicle. And so it's well worth doing, and it would make a difference to emissions. Where emissions from electricity production in states where it has fallen below 500 grams per kilowatt hour, we should incent the purchase of electric light vehicles. We could do that with a rebate program, a loan, low interest loan to a buyer. We could do that with a dividend paid to the selling company, something to reduce the price so that those vehicles could enjoy a bigger market faster. The reason there is a emissions limit on here is because once you get over 1,000 grams per kilowatt hour, your electric vehicle isn't as big a emissions winner compared to just driving a hybrid, for example. We could support existing building efficiency improvements by providing tax credits for documented changes in energy use. This has been done before. This could be done to convert lighting, insulation, air leak improvements, high efficiency heat pumps. There's a whole list of things that could be done to fix buildings, to make them more efficient, and a lot of these things would be useful to do. I believe we should pass a carbon fee and dividend act like HR 763. I'm not wedded to the particular details of HR 763, but the idea of such an act is to incentivize individual behavior. People will come up with all sorts of creative solutions if you give them an incentive to do so. And it is the free market thing to do, to give people a reason to go out there and be creative. So the idea of step one is do this stuff as quickly as possible and capture. Now I put 500 gigatons there. If we did these things effectively, you would get more than that. Some of these are going to be up and down. Some of them may not be as easy to get done by 2035. But these are the kinds of things, this is the kind of leadership it's going to take to get us back to the 2-degree curve. And you might get more like 700 or 800 gigatons out of here. Again, a lot of it depends on the details. And I wouldn't dare to put a real number on it. It's really a suggestive. I put 500 up there as a suggestive. Now, what's my step two? My step two is to electrify everything using inexpensive financing. So what I basically want to do is use financing as an energy tool. I got this idea from a guy named Saul Griffiths. He was interviewed on an Ezra Klein podcast. Ezra Klein is a commentator for Vox Media. And Saul Griffith is a CEO of a couple of companies, an inventor, a physicist, with plenty of creative ideas. And one of those I think that's very interesting is he pointed out the role of FHA loans and the invention of the auto loan in the 1930s, all of which spurred transitions to cars and home ownership and other things. And he's proposing that we should try and incentivize that kind of transition to a more complete electric infrastructure. So what do I mean by electric infrastructure? Well, basically everything in a building that would be used would run off electricity. Your heating, your cooking, all that kind of stuff, air conditioning, and of course all the appliances and everything else. And then you would try and convert as much transportation as possible, much road vehicle transportation of as much as possible, as much manufacturing, and even some of the agricultural machinery that runs, you try and electrify as much of that as possible. At the top of this, it says, create a vision of plenty, not sacrifice. And what I mean by that is to motivate people to make this transition. I think we need to point out that these technologies are going to lead to a new, more expanded and cleaner and cheaper way of living, more efficient way of living. Electric cars are much more efficient, have lower maintenance than industrial combustion engines. There's plenty of data around that shows it. If you remove natural gas for cooking and heating out of your house, you get less particulate matter, less pollution in your house. Natural gas is clean burning compared to a lot of other things, but it's not clean burning. There's a lot of evidence that shows natural gas in an airtight house is not a great thing for human health. So I think we've got the idea a lot of times in the environmental movement that it's all about doing less, sacrifice and so on and so forth. I don't think that's the vision that I see for our future. The vision I see for our future is us living more prosperously in a cleaner environment that has lots more opportunity for everybody. And I think we can do that with this kind of electrify everything strategy. Now, to get here, we have some barriers we've got to overcome. We need to get started on developing electric storage capability. There's two kinds of storage. There's power storage, where where you get spikes in demand. Somebody demands power in a short time window. And batteries, flywheels, large capacitors, those are good at supplying energy per second, right? They're good at supplying energy in a short period of time, but they're not good at supplying energy over a long period of time, storing energy over a long period of time. So if you put energy in a battery, maybe 4 hours later, you can get it back out and it'll be fine. But if you want to store energy from production in the summer months to production so you can reuse that energy in the winter months, batteries aren't an answer for that. You need a different kind of storage for long-term energy storage. And we're talking about systems like pumped hydro, where you pump water up a hill and then bring it back down when you want to use it, or these things called salt batteries, which are very large batteries run with inexpensive electrolytes. There are other ideas, but we really need to get these ideas developed. Now, this is not a basic research question. This is really a development question. And so we really need to do some scale model, some pilot level plants that do some of this, especially in the energy storage area, long-term energy storage area. That will be a barrier for electrifying everything. And finally, we have vehicles and some other applications that need very dense energy fuel capability. In other words, we need to be able to carry in an airplane in a relatively small volume fuel capable of powering that airplane for a long flight. And so we need a dense fuel. batteries are way too heavy for that. And, you know, so what we need is something like hydrogen fuel cell type technology. Perhaps we could use renewable sources when they're not powering the grid to make hydrogen by electrolysis to provide this dense fuel capable to power these large trucks. There are other ideas for dense fuels that we might be able to use renewables to make, but this is one idea that's out there. So I would drive at these things. And then after 2050, it's really transitioning to breakthrough technologies. By then, I think we should be able to use Generation 4 nuclear, especially in northern latitudes. It'll be, if we do it right, the reactors will be very, very safe and small scale, so they could be produced in a reproducible manufacturing environment. Every water-based nuclear reactor, water-cooled nuclear reactor that's built today is built as if no one ever built a nuclear reactor before. They're all one-off construction projects, each its own piece of art. We want to build them like Chevy trucks, one after another off the assembly line. And to do that, they need to be smaller, and they need to be safer, and they need to be easier to build. And we can get there with these Generation 4 reactors. We have pilot models that are working. We just need to work out the last details. But it might take a few years to build enough of them to test out all the ideas. We need to build negative emission technologies like direct air capture. Let me just show a little bit of these. This is a drawing on the left that shows you remember before I showed the business as usual curve and the 2-degree curve? Well, this is a drawing from UNEP, UNEP. That's the United Nations Energy Program. And it points out that if you follow the 2-degree curve out to somewhere out around 2050 or so, to get to where we want to go to guarantee and stabilize on 2 degrees, we need to start taking CO2 emissions out of the atmosphere. That's the blue color down there. So basically, the brown is what's been emitted. The green is what we mitigated. In other words, by not following the business as usual, we took the green out so we didn't have to follow the business as usual. That's the mitigation. The brown is what we actually emitted. Excuse me. And the blue is what we're trying to take out of the atmosphere. So we need these negative emissions technologies to guarantee the 2 degrees stays. So when we get to 2100, we really don't go above it. So what are these technologies? Well, there are several of them, and it's not like we have to wait forever to get started on these things. There are some that will require development. For example, there's something called coastal blue carbon. This is basically building, renewing the biomass along our coasts in the form of mangroves, swamps, seaweed, various kinds of grasses, marine grasses, things like that, that will sequester a lot of carbon. We can accelerate the chemical weathering of rocks. We can capture CO2 by air or in carbon emitting plants like biomass burning plants, and sequester it in underground formations. Now, I mentioned that I have some concerns about that, but it is possible that we can direct air capture carbon dioxide and also use it to in a weathering type process and turn it into mineral rocks like calcium carbonate that would chemically capture the carbon dioxide. We can reforest or prevent the destruction of forests, which would build CO2 in the biomass as well as in the soil. And then the last one says we can do a lot about enriching the carbon in the soil. A lot of our agriculture today depends on large amounts of fertilizer, because we basically suck the carbon out of the soil by going deep, planting densely, and doing all the things we do the way we do it. There are ways to improve the capture of carbon in soil and still do some farming. A lot of those need to be further developed and made into production scale. So these are some of the competing technologies for negative emission, and we need to keep working. The center ones are things that we need development of technology, the ones for direct capture and carbon sequestration and carbon capture in plants. The coastal blue and the afforestation, reforestation, and carbon and soil carbon are all things we could start on today. Okay, well, that's the description of where I think we need to go, and you will notice that that's a rather ambitious program, but it's what's needed to get us into a safe place for our grandchildren to have a world that's not that much warmer than our world, hopefully. So I want to summarize the whole course in one slide, and it's basically got just a few things here which I will go over with you. It's, in my mind anyways, it's downright silly to question whether the Earth is warming anymore. I recognize that if you go back to maybe 1980, you might say, well, you know, how much is this, you know, these data are difficult to pull together. I'm not seeing a big signal yet. Maybe it would be fair then to be skeptical. I think in 2019, the data is so strongly pointing to warming. The many ways that we can accurately today measure the influence of warming is just overwhelming. The evidence is overwhelming. So I'm hoping that people think this is not a question anymore. How much it's warming, of course, is the question we discussed at some length, and you know, is showing what I think is a significant warming trend. When you get down to what's causing it, I think it's clear that for the most part we are causing it. We are doing that primarily by emitting greenhouse gases from fossil fuel burning, but also from land use, and that there are various feedback effects that we know exist in the climate system that will enhance the warming, like albedo loss when you lose ice and snow on the surface, like the increased moisture in the atmosphere, all of which we can measure and point to, right? And so it's hard to escape those results at the moment. One of the things that's happened on these first two summary points is that since in 1970 or so, 1980s, the United States did a tremendous job of putting satellites in space, a lot of them called Landsat satellites, various satellites that we are now getting very good data from that are really helping us understand this problem. So I talked about a few satellite systems, the GRACE satellite system, which is a gravitational measurement satellite that can sense how many tons of ice are in the continent, like Greenland. The JASON satellites, which are altimeters across, they cover 3 JASON satellites that cover the Earth and measure the distance, accurately measure the surface of the Earth, the surface of the oceans. And I could go on and on, there are others. These are fantastic pieces of gear that we simply didn't have back in the 1970s and 1980s when people were building the foundation of this piece of science. And I think today they have added so much in terms of confidence and new measurements that can tell us where we're going when we see these things changing in the future, that we're going to have, that we both can confirm these first two statements, but also can point to how this is changing over time, and give us, have already given us kind of an early warning system, and can give us a path along there as we go forward in the future to get people more information, to help get people motivated to do things. I should continue. The complexity of the climate system makes it difficult to be totally accurate about predicting, but a 2 degree C increase is likely between 2050 and 2075, 2080. To stay below 2 degrees by 2100 is going to be very difficult. I showed you a program that I think has a chance, but it takes a tremendous effort to do that. A more realistic person might say we might be at 3 degrees, and that's scary. And so there's where we might be. The effects of even 2 degrees will require substantial adaptations at considerable expense. It's difficult to say how much expense, but we are going to require adaptations in a lot of areas, and we cannot tell for sure what sort of complications may arise from even a 2 degree change in terms of agriculture, sea level rise, so on and so forth. Serious damage and threats from tipping points cannot be ruled out. I went over several tipping points. One of the concerns we have there is the science behind these is just emerging. And you might say, oh, good, that means we can ignore them. Well, I say, no, there's evidence to be worried. The fact that we don't understand them is what I'm worried about. And if you could quantify the risk, then we'd have a better chance to say, well, maybe we could adapt to this, or maybe we could do this or that. But without being able to do that, without being able to say, you know, that 2 to 4 feet in 2100 could be more like 10 feet sea level rise, knowing that a lot of Florida is 5 feet above sea level, is a scary proposition, right? So those are things that a lot of people like Nordhaus, many climate scientists, many climate scientists, many economists, even many political leaders believe, you know, we really shouldn't be taking that chance. That's why the 2 degree C is bandied about so much. There's much we can do to limit emissions. We've gone through a lot of that. There's a lot of technology that needs to be developed. There's a lot of stuff out there we can do today. Our carbon budget between now and 2050 is 1,000 gigatons or so, round numbers, to make sure we stay on the 2 degree C warming curve. You saw that getting 1,000 gigatons saved between now and 2050 is not going to be done with you and I going out and buying a more efficient car. It's going to be done with a lot more global effort than that. It's going to be needed a lot more global effort than just motivating people to be slightly more efficient. We are not going to get there on efficiency alone. We're going to have systems changes. Finally, we need to fund substantial R&D and negative emission technologies. And around 2050, it's likely we'll need to take more CO2 out of the air to ensure stabilizing the temperature around 2 degrees C. Okay, so that is my summary of the course. I really do appreciate the fact that you have taken the time, even if you bounced around the talks and found the ones you liked or thought were most useful for you. I hope this information has been of some use, and thank you for taking the time to go through it.